So let's do a quick recap of what we discussed last time. We discussed about the clock, what is clock, and how the activities in the digital circuits are synchronized based on the clock. Either it's a positive edge of the clock or synchronized at the negative edge of the clock or at the levels of the clock. So we have discussed that we will be focusing on the edge triggered devices, which is flip-flops, which means that we will be focusing only on the positive edge triggered devices. We also talked about the clock period. So the clock period is this, from one high level and then one low level, and the inverse of a clock cycle is generally referred as frequency. The clock cycle or the clock period is the same thing. Okay, and we discussed these examples like if the clock cycle time is 1 nanosecond. Cycle time means from the duration between this positive edge of the clock and this positive edge of the clock is called the cycle time. If it is, let's say, 1 nanosecond, then the frequency or the clock rate would be 1 gigahertz. And as I mentioned, that we will be discussing only on the edge triggered devices. We also talked about the D flip-flop, and we discussed that if the data is changed, the output is updated only on the edge of the clock, the positive edge of the clock. Okay, so if the data is changed here, it is not reflected directly at the output, rather it waits for the clock edge to come in, and then after a certain delay, which we call propagation delay, the input is updated at the output. Okay, get it? Any question? So T stands for the time. We said that it could be any time, and T plus 1 means the plus 1 corresponds to the next coming edge of the clock. Okay. All right, so based on this discussion, we need to proceed ahead with talking about the performance. So if I were to ask you about how do you calculate or how do you evaluate the performance of an airplane? So let's suppose we have to define the performance of an airplane in terms of a speed. Okay, so there are different metrics. You can say that there might be two possibilities. You can say that a certain plane is faster if it is carrying only one passenger from one end to another end in a minimum amount of time. Or we can also say that plane would be considered faster if it is carrying 450 or more passenger in a minimum amount of time. Okay, so there are different possibilities, different metrics, and the performance not only depends on a single metric, but there are a couple of them which are connected together. As same as we calculate the performance of an airplane or anything, we have to calculate the performance of a computer. Okay, so the computers. Okay, I'll hold on for a while. So you just came out of trauma?
Probability test, yeah.
Okay.
That was one of the hardest tests I've taken in a while.
That's why I said you just came out of trauma. Relax. Take a sip of water. Okay, so we have been talking about calculating the performance. We just randomly discussed the performance of a certain thing like an airplane, and we were now going to talk about the performance, how to calculate the performance of a computer. So the performance of a computer can be calculated depending on these two things, either response time or the throughput. So response time is also referred as the execution time. So response time is something like you apply input, how much time it takes to respond you back, okay, or how much time is required to complete a certain task. Okay, similarly, throughput means total work done per unit time. So if I give you certain activities to complete in 5 minutes, so how many activities you complete within a certain time limit, let's say 5 minutes, that is called the throughput. Okay, So how are response time and throughput affected by these two things? When we replace the processor with a faster version, so what will be affected? And when we add more processor, excuse me. So which one do you think, the response time or throughput, will be affected by the first one when we replace the processor with the faster version? The response time will be affected. Okay, so the response time will decrease. And adding more processor, we will be able to complete many more tasks in a certain amount of time. That is what we call the throughput. Okay, but in order to calculate performance in this course in the computer performance, we will be focusing only on the response time for now. Okay. Now, how do we measure time? When we are talking about the response time, how do we measure time? There are two different categories. Again, elapsed time and the CPU time. So we know that the computers are often shared, and when we are executing a certain task, like I'm running a presentation on my computer, but there might be some other tasks that might be running in parallel. Okay, so again, the elapsed time is the total response time, including all aspects, processing, IOs. I have connected the projector with my laptop, running this presentation. There might be some other tasks that are running in background. So that is all called the elapsed time. So in the elapsed time, usually the focus of the developer is to calculate the throughput, how many tasks are completed within a certain amount of time. As I said, we will be focusing only on the response time, so we will not talk about the elapsed time now onwards. We will be focusing only on the CPU time. So CPU time is the time spent processing on a given job. It is composed of two different times, CPU time, user CPU time and system CPU time. So user CPU time is the actual time that is processed by a program, and the system CPU time is something like if your program requires accessing the external port or retrieving the data from the external memory or something like that. So it's composed of everything related to the operating system performing tasks on behalf of the main program. Okay, so we will focus on CPU time, and we will not be splitting these two categories differently. We will just be treating the entire thing as a CPU time. Okay, so just a quick recap of what we discussed last time. When we have a clock period again is a duration of the clock cycle. It would be given to you in terms of seconds, and you can represent that. So this 250 picoseconds can be represented in this form. You just move the decimal point behind and you can represent it like 0.25 nanoseconds. So never get confused when you see a problem and representing the values in different units. Okay, again, giga, if you do not remember the value of giga and if you see a problem in your exam, you can ask me. I don't want you to memorize these things. So giga corresponds to the 10 to the power 9, and you can again move the decimal point to represent this into megahertz. Okay, all right, so we are learning to calculate the performance, and we will be focusing on CPU time. So we can calculate the CPU time with this formula. So CPU time is the amount of time taken by a processor to complete a certain task. Okay, so if you recall, I talked about the number of clock cycles, and the cycle time of each clock can help us identify what is the CPU time of a certain task. Okay, so just like I gave a very naive example last time, like can you calculate your own performance in terms of like a breath cycle? If you were to perform a certain task, how many breath cycles you take to complete a certain task. Similarly, if we were to evaluate a performance of a certain task, we can calculate how many number of clock cycles it is taking. And if you multiply that number of clock cycles with the one clock cycle time, it will give us the CPU time. Okay? And again, clock cycle time is inverse to the clock rate, so we can write this formula like this also. Again, whatever is given to you, if you are given a clock rate frequency, you use this formula. If you're given a clock cycle time, you use this one. Okay. So by looking at this formula, what do you think how we can improve the performance? So first of all, you should know how the performance of a computer in terms of CPU time is evaluated. Like if I say CPU time is evaluated by this formula, how can you say that the performance is improved? By increasing the clock rate. Of course, when you have a processor with a higher frequency, running at a higher frequency, the clock rate is frequency. Okay, so when the thing which is at the denominator, if it increases, of course it will reduce this factor, CPU time. And when the CPU time reduces, it means that your processor is able to complete the task in less amount of time. Okay, or what we can do is we can actually reduce the number of clock cycles. So when we reduce, so our aim is to reduce this factor. We can either reduce it by reducing the number of clock cycles taken by the task, or by increasing the clock rate. Okay, both of these things will help us reduce CPU time.